From the first blowout preventer to the first subsea tree, Cooper Cameron has pioneered many of the things you take for granted today. And as the industry's only supplier of drilling, completion, production, and compression equipment systems, we offer far more than isolated products. Our service solutions are often just as important as our manufactured goods. And now you can get Cooper Cameron dependability in pre-engineered, cost-optimized product lines with all the flexibility of custom-made. Innovative products, responsive, knowledgeable people, packaged systems. Add it all up and there's only one answer: Cooper Cameron. Nobody covers the oil field better. The challenge is to bring a newly discovered deep-water reservoir on stream quickly and with minimal expense. Also needed is flexibility for efficient development of a second undefined reservoir located nearby. Reservoir A lies beneath 6,000 feet of water and has estimated reserves of 250 million equivalent barrels of oil. The development plan for Reservoir A is to drill 5 producing wells, which will then be connected to a manifold and finally to a floating production, storage, and offloading facility. The FPSO will separate commercial quantities of crude oil and natural gas, store the crude for offloading to shuttle tankers, and redirect the natural gas to a subsea pipeline for transportation to an onshore processing plant. A second Reservoir B is located nearby and may be developed in the future. Although undefined at this time, Reservoir B is thought to contain approximately 150 million equivalent barrels of oil in 6,500 feet of water. Reservoir A plans should provide flexibility for developing this resource as dictated by crude oil supply and demand. An STM wellhead's 18 3/4-inch high-pressure housing featuring the new Cameron DWHC connector profile is lowered into the 30-inch conductor housing, which already has been set in the ocean floor. The extra strong DWHC profile is specifically designed to withstand the severe bending moments of ultra-deepwater projects. The passively activated preloaded lockdown system provides 2-point contact for proper alignment and effectively transfers axial and bending loads into the conductor housing. Passive activation means the lockdown happens automatically and, most importantly, without an extra trip of the running tool. Once the housing is locked in position, the conductor pipe can be cemented in place. A guidelineless 5-cavity TL BOP is lowered into position on the DWHC connector profile of the wellhead. Cameron invented blowout preventers in 1922 and has built more than all other suppliers combined. Our broad product line allows drilling contractors to safely anticipate and handle the widest possible array of reservoir and formation conditions. The TL BOP's innovative side ram removal feature reduces BOP height requirements and saves valuable rig time. Note the small size and footprint of the drilling control pods from Cameron Controls. This is made possible by use of miniaturized components that require less space and have lower power requirements. Low voltage solenoids eliminate the need for a bulky transformer. The lightweight control pods are totally ROV retrievable. If service is necessary, the ROV connects a wire line to the top of the pod and guides it away from the riser. Wet make-break connectors automatically disconnect as the pod pulls away and easily reconnect after service is performed. More than 75% of all subsea drilling controls sold in 1997 were by Cameron Controls. While 2 million pounds of applied tension load might have been sufficient for yesterday's subsea wells, Cameron's new Load King riser systems will handle the 3.5 million pound loads of today's deepwater projects. The rules are different when you're drilling in deep water, and Load King can take additional tension loads without adding significant riser joint weight. Its raised flange design reduces bolt stress, and it has a joint makeup time of only 2 minutes. After the BOP stack is landed and locked down on the wellhead, electro-hydraulic signals are sent from the control panel on the drilling rig to the control pod mounted on the BOP, and then to the BOP rams. Fixed bore pipe rams can be closed on a test tool as part of this test sequence. Pressure is then applied down either the choke or kill line. The new BBR2 ram packer features a unique curvilinear insert called cam curve that adjusts automatically to form an iris around drill pipe of different sizes. This reduces the need for ram or packer changes and provides uniform sealing pressure with virtually no extrusion paths for longer packer life. The 7-inch casing hanger is landed in the STM wellhead using Cameron's efficient and field-proven Chissart running tool. Other manufacturers' tools pressurize the BOP stack to pump casing hanger seals down, which drives and deforms the seals into a bowl-type cavity. Cameron's system sets seal assemblies by pressurizing down the drill pipe, which allows seals to set naturally before stack pressure is applied. Parallel bore metal seals are used between the casing hanger and the high-pressure housing to provide metal sealing from above or below. This means bidirectional sealing without loss of sealing contact pressure, which can occur with other systems using tapered seal surfaces. Once drilling is complete and casing has been cemented, the BOP is pulled to make way for the Christmas tree. Cameron engineers have developed a way to park the BOP using a freestanding Load King riser system, which eliminates the need to retrieve the riser and stack back to the surface, disassembling it section by section. The BOP is disconnected from the wellhead and moved by the drilling rig to a parking stump positioned nearby. After a shallow water disconnect from the riser, the rig returns to its previous position over the well. Buoyancy materials and air tanks allow the riser to float in a fixed vertical position until it's needed for final completion of the production tubing. The heart of a subsea production system is the Christmas tree, and Cameron offers 2 highly reliable and feature-rich trees as part of its pre-engineered mosaic system. One of these is the patented spool tree Christmas tree. Since its introduction in 1992, spool tree has revolutionized the subsea industry. The spool tree system's unique wellhead tree hanger arrangement lands the tubing hanger on a dedicated shoulder in the tree. This saves significant rig time by allowing completion and workover operations to be performed with the tree in place and flow lines undisturbed. The horizontal valve assembly provides an unobstructed vertical path to the well. Gate valves can't be damaged by wireline tools because wireline tools are not run through them in the spool tree design. The procedure for locking down the spool tree to the wellhead is simple and reliable. All spool tree connector hydraulics are contained in the running tool, which means that no hydraulic cylinders are exposed to subsea conditions long term. An ROV backup lock is available should the primary locking device fail. The drilling rig now moves over the parked freestanding riser and BOP assembly. The upper riser section with a collet connector and non-sealing shear ram is lowered over the parked lower riser section. Once the collet connector locks around a mandrel hub on the lower section, the entire riser BOP stack is picked up and moved back in position over the well. The riser and BOP are lowered and connected to the top of the spool tree Christmas tree. This saves several days of valuable rig time over the more conventional procedure of pulling the riser and BOP to the surface. The spool tree body can be machined with a choice of 3 18 3/4-inch connector profiles on top for use with a standard blowout preventer. In fact, with spool tree, all completion activities can be performed under full BOP control. The spool tree design lands the tubing hanger in the tree with full-bore vertical